Okay, grade 12 college prep physics, looking at maybe the least normal force of them all, but we call it the normal force. And what it is, just briefly what it is, it's a way of explaining, why something doesn't fall through the floor. And what it's like, we think about motion being the result of unbalanced forces, right? Or acceleration being the result of unbalanced forces. And so, if this guy's standing here, we know that, we're thinking about a free body diagram, we draw gravity down, right? There's got to be some reason he's not moving. And of course, in our mind, it's just, well, it's because the floor. And so the normal force is what we use to explain the floor, right? The thing that's balancing gravity so that he doesn't accelerate towards the center of the earth. Okay? So it's actually a made up force. But, it is based on something kind of real, which is an electric force. Because in reality, you probably remember from grade 9 science, talking about the structure of the atom, and you got the nucleus, which is really small, and then you got the electrons around the outside, but most of an atom is empty space. And because most atoms are empty space, theoretically, any surface you touch, you're not actually touching, because surfaces isn't actually stuff. Surfaces is empty space. Atoms is stuff, and so anything you touch is stuff. And so you're touching mostly empty space, and you may sound silly and you don't buy that. But the reality is what you feel when you touch something is an electromagnetic repulsion between the electrons in your hands and whatever you're touching. And so what force is actually keeping this guy here from falling through the ground is the repulsive forces between the electrons in the material that makes up the floor and the electrons in the material that makes up his shoes, and then his shoes to his feet, and etc. And so it's actually almost appropriate that the picture shows him sort of hovering above the floor, because in honesty, that's all we do. So normal force is an electric force. It's an electrostatic repulsion. But, we don't get into that at all. We just call it the normal force, and we say it's the force of the floor, balancing gravity. Okay, moving on. Something about normal force that we use for all our considerations is that it's always perpendicular to the surface you're resting on. So, for example, this guy's sitting on the top of the slide, and there's a normal force pushing up on him. This guy's on the slide, and the normal force is pushing on an angle because he's on an angle. And so, see, if I was going to draw a right angle there, right, there'd be a right angle right there, 90 degrees, where my little mouse is. If you were leaning against the wall, then the normal force would be directly horizontal, like directly in the opposite direction as your hand, right? So that's the direction of the normal force. From our purposes, especially in this class, we almost always just consider the normal force to be an up-down force, or up force. I think of, sort of the strength of normal force, whatever, in terms of like the pressure between two surfaces, because it is the force that keeps you from falling through the ground, right? You're standing on the ground. But if someone pushed down on you, like, this guy's getting pushed down on, then what we call the normal force is actually greater than if this guy pulled his thumb up, right? So this guy lying down has a normal force that's actually equal to his gravity force. He's got balanced forces on him. And then the guy comes and pushes down with his thumb. And when he pushes down with his thumb, he increases the pressure between the dead guy here on the floor and the floor itself. Okay? So if you push down on something, you increase. Now, on the other hand, if you kind of pulled up but didn't quite pull him off the ground, but just pulled up a little bit, you can almost imagine you reduce the pressure a little bit between this guy and the floor. That's decreasing the normal force. So normal force is kind of a balancing force that way. So if there were no thumb pressing down on this guy, then the normal force would be just equal to his weight, which is just gravity, right? Since the thumb is pressing down, the normal force will be greater than his weight. So now we got this, I guess we'll say it's a dead body here. So if no one was pulling up on this dead body, then the normal force would be equal to the dead guy's weight. The normal force that would be between this guy and the ground, right? Pushing up on this guy. But since someone is pulling up on him a little bit, that's decreasing. So again, if you push down, you're increasing normal force. If you pull up, you're decreasing, because you're sort of decreasing the pressure between this guy and the floor. You can almost see he's being lifted up a little bit. So if we want to calculate normal force, so this poor guy, his mass is 72 kilograms. And the massive thumb presses down on him with a force of 100 newtons. What is the normal force between the dead guy and the floor? So normal force in most applications is just equal to gravity, because most of the time you don't have a giant thumb pushing down on you or something pushing down on you. Most of the time an object just rests and sits there. And so the normal force is equal to the gravity force. However, if you have a case like this, now we have an added force pushed down. So looking at the free body diagram, I'm just calling N for normal force, okay? So here's the free body diagram, mass of 72 kilograms. We got the mg, like the gravity force is pushing down on him, right? There's gravity, his own gravity is pushing down on him, but also this 100 Newton normal force, or not normal force, 100 Newton thumb force. This is the thumb, the giant thumb. So that's the downward force. The normal force has to be equal and opposite to that, okay? So we know the gravity is 72 times 9.8, so there's the gravity force. And then the idea with finding normal force is it's just the force that makes the up forces and down forces equal to each other. Now, if you're on, just a little side note, because what you will do as one of our activities is that related to this topic of normal force is we're going to ride an elevator standing on a scale. And we'll talk about it more at the time, but the idea is that, the scale is kind of a measure of your normal force. It's actually not a measure of your mass. You can approximate your mass from it, but if you think about it, and you'll see when we're on the scale, what happens when the elevator goes up and down. So sometimes, it's not exactly balanced. But like I say, in any real application that we're going to study, besides the elevator, when you're not moving up and down, the normal force just balances off the two downward forces. Anyway, so the down forces are equal to the gravity force plus the 100, so 806 newtons. So normal force has to equal those, so normal force is 806 newtons. So that's calculating normal force. And again, if there was no 100, if I just took that 100 away, then the normal force would just be equal to the 706. So if the thumb got lifted, then the normal force would change. And that would just, because you can picture it, the pressure between the guy and the ground without that thumb is going to be less. So it should be less of a normal force. Another example. Elevator. Yeah. So this kid is 27 kilograms standing still on the elevator. What is the normal force between him and the floor? So this isn't exactly our example. He's in an elevator and he's just standing there. Okay. And so what is the normal force? And this is the most typical question. So you've got, there's the kid, the free body diagram, normal force equal and opposite to gravity. Okay. So up forces equal down forces, so normal must be equal to gravity. And like I say, most times that's the situation. Most times normal and gravity are equal to each other, so normal is equal to mg. And then you just go 9.8 times 27. And of course, here's what I was sort of hinting at with the elevator. Okay, so that's calculating normal force. I think that's it for this note. And yeah, the next thing to do is elevator, a couple questions, and of course the little quiz on Schoology.